Okay, so we used our sum formulas. In our sum formulas, we know that sine, cosine, cosine, sine, cosine, cosine, sine, sine. Well, if we have 2x, that's the same thing as sine x plus x, so it would be sine x cosine x plus cosine x sine x, which is sine x cosine x plus sine x cosine x is 2 sine x cosine x. Okay, that's a straight application of our sum formula. Same thing with cosine. Its cosine is cosine of a number plus a number. Cosine of x plus y is cosine x sine y minus, cosine x cosine y minus sine x sine y. So if both of them are the same, x plus x, then you'd have cosine x minus sine x, which is cosine squared x minus sine squared x. Very good. So these are two straight, kind of derivatives or the next levels of our addition formulas. Now, there's different ways you can rewrite this one because we can also use our trigonometric identity, sine squared plus cosine squared equals 1. So if I substitute in here, instead of cosine squared, I substitute 1 minus sine squared, then I'd have 1 minus sine squared minus sine squared, I'll have 1 minus 2 sine squared x. So this is another way for the double angle for cosine of 2x. So cosine of 2x equals this one, or the other way I could do it, instead of substituting for cosine squared of x, I could have substituted for sine squared of x. Instead of sine squared, I could have written 1 minus cosine squared. So I'll have minus 1 minus cosine squared. So then I'll have 2 of the cosine squareds. And if I have 2 cosine squareds, I'll have minus 1 there. So 2 cosine squared x minus 1. So these are for our double angles for sine x and cosine x. Now, if we have tangent x, so if I wanted to look at tan of 2x, again, this is a straight application from what we had for our double angle. We end up getting 2 tan x divided by 1 minus tan squared of x. Okay? So these are my double angle formulas. All right, let's put them to use. Let's practice. Suppose I want to find cosine of 2x. I know that cosine x equals negative 2/3. So what do? Well, and we also know x is in quadrant 2. So what do? Well, first off, we know that cosine of 2x is 2 cosine squared of x minus 1. So I'm going to use a different colored pen here. This is equal to, oh, wrong, bad color. Get a different color here. Here we go. This will equal 2 cosine squared x minus 1. We know cosine x equals negative 2/3. We'll have 2 of negative 2/3 squared minus 1, which is 2 times 4/9 minus 1, 8/9 minus 9/9. Turns out we get negative 1/9. So after all is said and done, I get negative 1/9 for cosine 2x. What about sine 2x? Well, we know sine 2x is 2 sine x cosine x. So this will equal 2 sine x cosine x. But we already know what cosine x is, right? We know that cosine x, according to this, is negative 2/3. We know that we're in quadrant 2, so that means that the sine value is positive. So if we looked at sine squared x plus cosine squared x equals 1. We know cosine x is negative 2/3 squared. So I'll have sine squared x plus 4/9 equals 1. Subtract it over, and I get sine squared x equals 5/9. Square root both sides. It's only the positive one. Sine x equals the square root of 5 over 3. Why is the positive one? Because we're in quadrant 2. 1 second. So I'll have here square root of 5 over 3, and then we multiply that out. What we'll do is multiply this out, and then you get negative 4 root 5 over 9. Okay, let's take a look at an example of using our double angle formulas to prove this identity. Okay, so we're going to start off the left-hand side. Okay, just in this case, it's the hard-looking one. Okay, we're going to start off here. Now notice this sine of 3x. Now we don't have a triple angle formula. We do have a double angle formula. So we can note that sine of 3x is the same thing as sine of x plus 2x, right? It's the same thing. Okay? So now we can use our sine of a sum, right? With our sum formulas. So, okay, fine. So we know that sine, cosine, cosine, sine. So we can have this as sine of x cosine of 2x plus cosine of x sine of 2x all over my sine x cosine x. So I just used our application that was in 7.2 of the sum, sine of the sum. We get this sine, cosine, cosine, sine. Okay, so that's where we're at right there. Now, what do we know about cosine 2x and sine 2x? Well, we have these formulas over here that we can use. So if we have sine of 2x, we can rewrite that as 2 cosine squared minus 1. That's one possibility. And for cosine x, we can write, or excuse me, yes, what did I say? For cosine x, we can write 2 sine, for cosine of 2x, we can write 2 cosine squared minus 1 right here. And for sine x, we can write 2 sine x cosine x. So this will equal 2 cosine squared x minus 1 plus cosine x 2 sine x cosine x okay. So there, I did a substitution. Okay. Now, after you do that substitution, note that we can look at this as kind of two fractions, kind of this fraction and that fraction. Okay, so I'll have this fraction plus that fraction. Now, if I have this first fraction right here, you'll note that the signs cancel out. So this will be equal to, I'm kind of running out of room here, 2 cosine squared x minus 1 over cosine x, and over here, this fraction, the cosines will cancel, plus 2 sine x cosine x, and actually the sine x and the cosine x will cancel, so I'll just have 2, what do I have? 2 cosine x, excuse me. And then if I break this up even further, this will equal, this fraction minus that fraction, so I'll have 2 cosine x, so 2 cosine squared over cosine is just 2 cosine x, and minus 1 over x, which is what? Minus secant x. So that'll equal 4 cosine x minus secant x, which is the right-hand side. Okay? All right. Okay, double angle formulas. Now, what happens if we take the cosine of 2x equals 1 minus sine squared x and kind of manipulate it a little bit? Notice that if I have cosine of 2x equals 1 minus 2 sine squared x, okay, and I kind of isolate sine squared, if you will. So I'll add sine squared over here. Okay, and I'll subtract the cosine of 2x to the other side. Divide by 2. Now, what this does is it enables us to write a square of sine to be equal to something that does not have a square in it. So we're actually lowering the power. We're writing sine squared as something that has no square in it at all. So this is one of those formulas that we're gonna remember, and it's generated simply from looking at this guy, which are generated from those sum formulas that we had for sum of sine of a sum and sine of a difference, okay? And cosine of a sum, cosine of a difference. Now we do the same thing, so this is 1 Okay, if we do the same thing now, if we have cosine of 2x equals 2 cosine squared x minus 1, and again solve for cosine squared, we'll have 2 cosine squared x equals cosine of 2x minus plus 1, excuse me, and divide by 2. I get cosine squared x equals cosine of 2x plus 1 divided by 2. Again, I'm lowering the power of cosine. I'm lowering it from a square now to I'm writing it as in terms of with no square, okay? And that's kind of beneficial. It's beneficial not only in this class but also in a calculus type course. So then if I wanted to calculate, say, what tan squared of x is, well, tan squared of x is just the quotient of sine squared over cosine squared. So you have this guy divided by that guy. The 2's are going to cancel out, and we'll get 1 minus cosine of 2x divided by cosine of 2x plus 1. Okay, so those formulas right there are for lowering powers. These are our lowering power formulas. Okay. All right, so again, they're generated just simply from these guys. Okay, given our formulas here for lowering powers, I'm going to do a simple substitution to get kind of a new formula for our half angle formulas. What I'm going to do is instead of x, I'm going to replace it with something called, it's a substitution. Instead of x, I'm going to write u over 2. So whenever I see x, I'm going to write u over 2. I'm just doing a substitution. So if I rewrite each one, I'll get sine squared of u over 2 equals 1 minus cosine of u over 2 times 2 divided by 2, which equals 1 minus cosine u divided by 2. Now, if I take the square root of both sides, plus or minus, I get sine of u over 2 equals plus or minus the square root, 1 minus cosine of u divided by 2. And this is a half angle formula. So if I want to find something that has it's a form of a sine of a number divided by 2, I can simply use this formula. Now, the choice of plus or minus depends on the quadrant in which this thing lies. Okay, the choice depends on the quadrant in which that guy lies right there. Okay, all right, and then you can do the same thing for cosine squared. So there's 1, and then there's cosine squared of u over 2. I'm replacing x with u over 2 equals 1 plus cosine 2 u over 2 divided by 2, which equals 1 plus cosine of u divided by 2. So if I take the square root of both sides, plus or minus, cosine of u over 2 equals plus or minus 1 plus cosine of u divided by 2. Okay, so there we have two of our half angle formulas. It's a half of an angle. Okay. Now, if we use tangent, if we do the same thing with tangent, we can go through that same process. Note that if we do use tangent, you can multiply by the conjugate, top and bottom, and it does simplify a little bit if you do that. And I'll let you guys explore that as you go. And the bottom line is that when we put in u over 2, and the 2's are going to cancel, the 2's are going to cancel. You multiply by the conjugate. The conjugate in that case is 1 minus cosine u. And if you have 1 minus cosine u and you simplify it a little bit, you end up getting something really interesting. You get 1 minus, okay, 1 minus. And again, just if you multiply both sides by that 1 minus cosine of 2 times u over 2, multiply by the conjugate, things work out kind of nice, and you'll get 1 minus cosine of u divided by sine of u. Okay. Okay, and those are our half angle formulas. Next, we'll take a look at an example for using the half angle formulas.